All right, Longhorns, this is the review for the 6-week CFA, and I'm going to go through this rather quickly. So if you needed further explanation, please attend tutorials Tuesday morning before the test, and I wish you lots of luck. All right, for this first problem, we're finding the horizontal asymptote. So just remember, when you're looking for the horizontal asymptote, to use Bobo Botten eats DC, and you want to look at these first terms right here, the first numerator and denominator coefficients, to see what your horizontal asymptote is going to be. If the power of the x term is the same, then you have it. Exponents are the same. That's an eats. So you divide coefficient. So DC. So 2 over 1. However, you still have this plus 1. So what you need to do is you need to add that 1 to the 2 that's already here. So your horizontal asymptote is going to be y equals 3. Okay, for a problem like number 5, we are trying to find the y-intercept. So to get the y-intercept, we just make x 0 and solve for y. So y equals a -6 over 3, or -2 in this case. And so we would say when x is 0, y is -2. And that is your y-intercept. In problem 6, we're looking for the wholes. So the first thing we need to do is factor. Okay, on this problem on your review, don't forget to change 18 to 8. That was a typo, so that needs to be corrected. So go ahead and change the 18 right here, change that to 8. And then we factor that, we get x minus 4, x minus 2. And then in the denominator, we get x minus 4, x plus 4. So right here, we have a whole. And so we're going to solve for x. And when we do that, we get that x equals 4. So wherever x equals 4 on our graph, we have a whole right there. But we also need to find the y value for our whole. So we have our x value. So what we're going to do is we're going to take this other part that we did not cancel out, and we're going to plug this 4 in for x. And when we do, we get 4 minus 2 over 4 plus 4. And that gives us 2 over 8, which equals 1 over 4, or a quarter. So when x is 4, y is a quarter. And that is where our whole is located. All right, for this problem, we are going to determine the vertical asymptote. And so we're going to factor again in order to determine the vertical asymptote. That's going to come from the denominator. Okay, as you can see from what I factored, we don't have any holes in this particular rational function. So we're going to need both of these values for our asymptotes. So if you wanted to check this, you could graph this in your calculator. Make sure you put the numerator in parentheses and the denominator in parentheses and graph it, and you'll see that it actually has 2 vertical asymptotes. One of the vertical asymptotes is going to be located at x equals 2, and the other vertical asymptote is going to be located at x equals -2. Make sure you're writing your vertical asymptotes as equations of lines. In problem 10, we're going to determine the x-intercept. Again, we're going to factor first, and then we're going to get the x-intercept from the numerator anywhere there's no whole. Okay, once I've completed the factoring, I cleaned it up a little bit and rewrote it over here to the right side. This ends up being x times x minus 4 times x plus 3. The denominator ends up being -2 times x minus 2 times x plus 2. So that's this completely factored. All right, so I'm looking for holes. I don't see any holes here. So now what I'm going to do is just look at the numerator for the x-intercepts. So for the x-intercepts, I just want to look up here. So I need to set each one of these x's equal to 0 to get my x-intercepts. I have an x-intercept at x equals 0 for this first x. For the next one, I set that equal to 0 and I get x equals 4 for my next x-intercept. And for the last one, I've got x equals -3. Now, these are not lines. These are not asymptotes. These are intercepts. They're points on the graph on the x-axis. So the way I'm going to write these x-intercepts is like this. I have an x-intercept at 0, 0. I have an x-intercept at 4, 0. And I have an x-intercept at -3, 0. So make sure that you're writing these in the correct format for the answer that you're given. So you're giving an answer that that answers the question, where are the x-intercepts? And so those are points. So you definitely want to give your answer as a point. All right, for this problem, we're going to write the vertex form of the parabola. So there's a couple pieces of information we need. We need HK, and we also need the value for A in the front of our equation for our coefficient in front of our X or Y. So first thing we're going to do is determine which direction this particular parabola is opening. And since I have a Y equals, that means my directrix is going this way. Okay, that's a Y equals line, which means my parabola is either going to be opening up or down. And since my directrix is smaller than my vertex, then my parabola in this case is opening upward. And my focus is right there. So what I need is I need this point right here. I need this point. This is my vertex. So I need the vertex of my parabola. Well, the vertex of my parabola is going to have the same x value that my focus has. So what I need to do is I need to find out, well, where is it at? Because my directrix is at -41/4 and my focus is at -39/4. So I know my vertex is in between those two things. So I need what's in between -39 and -41. Well, that's -40. And -40 divided by 4 is -4. So I'm going to go ahead and write down my center. My center is -6, -10. -40 divided by 4 is -10. So now all I need to write my equation is I need the value for A. Well, you need to remember this formula. A is equal to 1/4P. Well, what is P? Well, P is this distance between the focus and the vertex, and between the vertex and the directrix. That both of those are P. This is P. So how far is that? Well, you can determine that by either you can add these fractions together and divide by 2, or you can subtract your -40/4 plus a 39/4. Anyway, you get that P equals 1/4. And so if you know P equals 1/4, then you can find A pretty easily. So A equals 1/4 times 1/4, which is just 1. So now we're ready to write our equation because we have everything we need. So it's going to be Y equals X minus H squared plus K. And our A value is 1, so we don't really need to write anything else. So just make sure that you know how to find the value for A with this given information. Okay, so with this problem, we need to identify the focus and the directrix. Okay, so we have the equation. It's some information we have that we know we can write down right away. Is we know the center is at 9, -1. And we also know that the value for A is -1/4. So what we need in order to find the focus and the directrix is we need to find out what the value of P is, because P tells us how far from the center we need to go, depending on what direction we're going. Now, this particular parabola is opening downward. So we know that the directrix is going to be up here and the focus is going to be here. So sometimes drawing a little picture of what's going on will help. So we need the value of P this time. And we get P the same way we got A before. It's 1 over 4A. So the value for A is this right here, -1/4. So if I do this calculation, -1 over 4, well, this just equals a -1. So I know my P is -1. That means that this value in between here is 1. And this value in between here is 1. So I'm adding and subtracting 1 from my vertex Y value. So my Y value is -1. So if I want to know my directrix, then I'm going to add 1 to my center. And my center Y value is -1. So to get the directrix, I'm going to add 1 to the Y value of my center. So my directrix is going to be at Y equals 0. Because if I add 1 to -1 right here, I get 0. So Y equals 0 is this directrix line right here. Now to get the focus, I need to subtract 1 from my Y value. So this is going to be -1 minus 1, and this is a point. So I need to make sure that I write my directrix, and this is my directrix. Okay, this was the Y equals 0 part. Now my focus is going to be a point. So I need to make sure I write that as a point. My focus is at 9, -2. So make sure you're writing them correctly. In this problem, we're writing the standard form equation of a circle, and we're going to start with finding the center and the radius. All right, for starters, I'm using the midpoint formula to find the center. I'm given the ends of the diameter, which are just 2 endpoints, and so I need to find the middle between those 2 endpoints. So I'm using the midpoint formula. So in the midpoint formula, we add the x's together, divide by 2, and we add the y's together and divide by 2. Do not get that confused with the distance formula, which is different. With the distance formula, we are going to subtract, which I'm going to show you in just a sec. So we found the center as -9, 6. Now we need to find the radius, and that's where we're going to use the distance formula. So now you can use the distance formula between your 2 endpoints and then divide by 2 to get the radius, or you can use your center point that you have found and use that with one of the endpoints of the diameter and find your radius. All right, so I've used the distance formula to find the radius. The radius is square root of 20. And I don't need to bother with simplifying that radical, because when I write my circle equation, I'm going to be squaring r anyway. So now I'm ready to write my equation because I know my center and I know my radius. All right, so my equation is x plus 9 squared plus y minus 6 squared equals 20. Okay, for this problem, we are finding the center and radius and the length of the diameter. All right, so I went ahead and I completed the square. All right, so I combined my x values, completed the square, combined my y values, completed the square, added these 2 values to the 78 on the right side. I got 112. So my equation is going to be for the circle x plus 3, the quantity squared, plus y minus 5, the quantity squared, equals 112. The center is at -3, 5, and the radius is the square root of 112. The square root of 112 reduces to 4 root 7, and the diameter is 2 times that. So 2 times r equals 8 times 4 times 2, which is 8. So the length of the diameter is 8 root 7. And that's it. We found all of the answers. Okay, for this problem, we are finding the center, the vertices, covertices, foci, the distance between the foci, and the length of the major axis and the length of the minor axis. So that's quite a lot to do. So let's start with identifying this. This is an ellipse, and so this ellipse opens long vertically because the a squared value is underneath the y. So that means that this particular ellipse stretches up and down the long way. And so I'm also going to take a moment to label my parts because apparently we're having a little bit of trouble with that. So this is my h, this is my k, this is my a squared, and this is my b squared. So for ellipses, the a squared value is always the larger of the two. So that's always the way the ellipse is being stretched. So in this case, it's being stretched along the y values. So the y values are being stretched longer than the x values. So it's stretched vertically. So let's get started. First of all, we have a center at -6, -3. And now what we need to do is we need to add and subtract our vertices. So what we need for our vertices, so what we need to know is we need to know the values of A, B, and C. We need those values in order to find the vertices, the covertices, and the foci. So let's just go ahead and determine what those are. Well, we know that A squared is 100, so A must be 10. We know that B is 25. B squared is 25, so B must be 5. So now we just need to know what C is. Well, C squared equals A squared minus B squared for ellipses. So C squared is going to be 100 minus 25, which is going to give me 75. So that means that C is the square root of 75, which is the same thing as 5 root 5, or 5 root 3, I'm sorry. 5 root 3. So C is 5 root 3. So now that we know what all those values are, we can go ahead and determine our points. So our vertices, we're going to add and subtract, because remember the vertices are at the top and the bottom of this ellipse. So I'm going to be adding and subtracting from the y value of my center. So to get the vertices, I'm going to add and subtract the value of A, which is 10, from my y value. So it's going to be -6, comma. If I add 10 to -3, I get 7. If I subtract 10 from -3, I get -13. So that's where the vertices are located. The covertices, I'm going to add and subtract 5 from my x value because that's where B is. So the covertices are these right here. So on these points, I'm adding and subtracting from my x value. So my x value is -6. So for my covertices, I'm going to add and subtract 5 from -6. So -6 plus 5 is -1. So -1, -3 is one of them. And the other one is going to be a -6 minus a -5, which is -11. So that's where the covertices are located. And then I'm looking for the foci. Well, the foci are going to be just inside along the same axis as the vertices. The foci are located there along the same axis as the vertices. So that means I'm going to be adding and subtracting my value for C, which goes along with the foci, my value for C from my y value. So my foci are going to be at the same value for x that my vertices are, but my other point for the y is going to be added and subtracted from, I'm just going to do add and subtract from my y value. So -3 plus or minus 5 root 3 is where the foci are located. All right, what else did we need? We need the distance between the foci. Well, If I just take my foci and I multiply times 2, that will give me the distance between the foci. That's going to be 10 root 3. And then the length of the major axis, well, that's just length of the major. All I'm doing there is adding my a to itself. So that's going to be a plus a, which is 20. And then the length of the minor is going to be the b added to itself, which is going to be 5 plus 5, which is 10. And that's it. Okay, for this problem, we are using this information to find the standard form of the equation for an ellipse. So let's go ahead and get our values for what we need to write the equation. We're going to need the center, and we're going to need to find A and B. Okay, first of all, I found the center pretty quickly. My x value for my center is going to be 10, and my y value for my center is going to be 3. So that's easy to find. Now we got to find A and B. So I'm looking at this ellipse, and it says the vertices are at 10, 14, and 10, negative 8. That means that this ellipse is being stretched the long way along the y. So since that's happening, then my A value is going to be right here along the y-axis. So what I need to do is I need to find the length between 14 and negative 8. So if you remember how we did that before, we took the value for 14 and we subtracted the value for the other point. So in this case, we are going to have to add. So 14 plus 18 gives me 22 divided by 2 equals 11. So I know my A value is 11. I'm going to do the same thing for B. In this case, I'm doing a 19 minus 1 divided by 2. So 19 minus 1 is 18, divided by 2 is 9. So my value for A, this length for A, right here, is going to be 11. And the length for B, this length right here, is going to be 9. And that's all I need to write my equation. Now I've got my center, I've got my value for A and my value for B, and now I'm ready. Now just remember that you need to write this value for A. This value for A needs to go underneath the y term because that's where it came from, the y term. All right, so I've written the equation x minus 10 squared over 81 because that value right here comes from B squared. So 9 squared is 81. Here we have y minus 3 squared, which is the direction that A is on. So we're going to put our A value underneath the y. And this is going to be 11 squared, which is 121. And that's it. We've written our equation for the ellipse. Okay, this problem is very similar to the last one, except this time we're working with a hyperbola. So you can tell it's a hyperbola because of this minus sign in between the terms. And this particular hyperbola is opening vertically. And I know that because my y term is first. So it's opening this way. And that's kind of important so you know where to look for things. So my vertices are going to be here. My foci are going to be on the inside of the curves. And my endpoints of my conjugate axis are going to be this direction. So these are the things that we need to find. We need to find the vertices, the foci, the distance between the foci, the endpoints of the transverse axis, which would be my vertices, and the endpoints of the conjugate axis. The first thing I want to find is the center. So there's a couple things I want you to do with these hyperbolas. I want you to identify H and K. This is H, this is K. and don't get them confused. This is a squared and this is b squared. Real important to identify these values in the beginning before you start calculating. That way you don't make any mistakes, because the center is not -5, 10. It's 10, -5. So very important not to switch that, because if you switch that, then everything else in your problem is going to be wrong. So one of the first things I do is find my a, b, and c. And I find a just by taking the square root of 36, because I know this is my a term, because on hyperbolas, the a squared always goes first. So the a squared term is 36 square root of 36 is 6. B is square root of b squared, which is 4. Let me change that. That should be 4, not 16. Okay, so I also need to find c. Well, I know that c squared equals a squared plus b squared for hyperbolas. So I take my 36, which is my a squared, I add it to my b squared, which is 16, and I get 52. So if I take the square root of that, that should give me the length of c. So I take the square root of 52, and I can reduce that to 2 root 13. That's going to be the value I'm going to add and subtract to get my foci. This is the value I'm going to add and subtract to get my conjugate endpoints. And this is the value I'm going to add and subtract to get my transverse endpoints, or my vertices. Those are the same thing. Okay, so let's start with finding the vertices, and then we'll find the others. Okay, so the first thing I did was I took my value for a, and I added it and subtracted it from my y value of my center. And I got that my endpoints are 10, 1, and 10, -11. For the conjugate endpoints, I added and subtracted 4 to the x value, and I got 14, -5, and 6, -5. And then for the foci, I add and subtract 2 root 13 from the y value. So I didn't write down the foci, but it would have been the same value as the center, except plus or minus 2 root 13. And then the distance between the foci is just the foci distance, which is c, added to itself, so or multiplied times 2. So I get 4 root 13 for the distance between the foci. And that's it for this problem. Okay, for this problem number 28, we're going to write the standard form of the hyperbola. So for the standard form of the hyperbola, I need the center and I need the values for a and b. All right, finding the center is fairly simple. All I had to do was look at the y value here for my vertices and the x value for my conjugate axis endpoints. And so this gives me the center, -10, 8. And then from there, I need to find a and b. So I know that a is going to run horizontal, because this particular hyperbola opens horizontally. The x values are changing, but the y values are staying the same. So if the y values are staying the same for my vertices, then this is my transverse axis, and this particular hyperbola is opening left to right. So that means that this is my a value right in here. This is my a value. And my b value is going to be going with the conjugate axis. So the first thing I'm going to do is calculate my a value. So I look to my vertices to find that. So I need the distance between -1 and -19. So I subtract that. So a equals -1 minus a -19 divided by 2. So I'm using that part of the distance formula. So -1 plus 18, -1 plus 19 is 18, divided by 2 is 9. So I know my a value is 9. My b value, I'm going to do the same way, except I'm going to use my endpoints of my conjugate axis. So I take the 10, I subtract the 6, and divide by 2. So 10 minus 6 is 4, divided by 2 is 2. So I know my b value is 2. And that's really all I need to know to write my equation, because I have my center and I have my a and my b. And I know that my a value is going to go underneath the x squared value, and I know the x squared value is going to go first because this particular hyperbola opens horizontally. All right, so I end up with x plus 10, the quantity squared over 81, minus y minus 8 squared over 4 equals 1. So make sure that you are able to do problems like this for your CFA. All right, for these we are classifying the conic section first and then writing its equation in standard form. So the first thing we want to do is get this equation set properly. I'm going to move everything over to the left side of the equal sign. All right, so I moved everything over. I've set it equal to 0, and now I'm going to start putting everything together. I noticed that my x squared term has a minus sign in front of it, and that my y squared term is positive. I want to put the positive term first. So I'm going to put y squared first. I'm going to combine it with its other like variable. And here we're going to complete the square. And then I have my minus x squared term. It doesn't have any other variables that go with it. And then I'm going to move the -5 over and make it positive. Now we're ready to finish this problem. We're going to complete the square, add the 4 to the 5, 2. This becomes y minus 2, the quantity squared, minus x squared equals 9. And now I'm ready to divide. Divide by 9. And my final equation is y minus 2, the quantity squared, over 9, minus x squared over 9 equals 1. Okay, so this is a hyperbola because of the minus. Now, if this was a plus, that would have been a circle, but it wasn't a plus, it was a minus, so that made it a hyperbola. Okay, the reason why I did this review this time for this 6 weeks test is because many of you were absent during testing last week for AP testing. So I just wanted to make sure that you didn't miss any of the problems that we went over in class. So I hope you take advantage of this video and just watch the ones that you need to. Work the problems out yourself first before you watch the video to see where you're making your mistakes. And I wish you the best of luck. Let's get hundreds on this test. We need the hundreds.